Okay, so I'm looking at the angles of elevation and depression exercise from my iMaths, starting with tab 1, and it starts off with the angle of elevation to the top of a tree. So the angle of elevation is the angle if you're standing on a horizontal surface looking straight up at something, the angle that you're looking up. So the angle measured upwards from horizontal, so 27 degrees as indicated in that diagram up to the tree. So let's just go to my whiteboard and have a look at question 1. So I've drawn the tree and the triangle that's formed by the tree and the point where you're standing, and then looking straight to the top of the tree and along the ground. So it forms a right-angled triangle. The angle is 27 degrees and the tree is the opposite side to the 27 degrees. So I've labelled the tree as the opposite side of the triangle, and then the longest side is along there, so that's the hypotenuse. You can tell it's the longest side because it's across from the right angle, which is between the tree and the ground. And then the 33 meters along the ground is the adjacent side. It's the one that's next to the 27 degrees that we're going to use, but it isn't the hypotenuse. So with opposite and adjacent involved in the problem, we're going to use tan. Tan equals opposite over adjacent. So in this case it's the tan of 27, so I'll just write tan 27 in there, degrees, and the adjacent is the 33, so I'll just write 33 in there, and then the opposite is the height of the tree, which is what we've got to find out. So tan 27 equals opposite over 33. That looks like a degree sign there, but it's not. Opposite over 33. So I'm going to multiply both sides by 33 to get rid of the fraction and just get the opposite side on its own. So multiply the right hand side by 33, it gets rid of the fraction and you've just got the opposite side. But then I've got to do the same the other side. So 33 times tan 27 is equal to the opposite. So I've just multiplied both sides by 33 there. So I'm going to just get that on the calculator now. Clear everything I had before. So 33 times tan 27 is equal to 16.8. So the height of the tree is 16.8 meters. And then let's just get on the iMaths and fill that in. Okay, so it says to do them to the nearest meter, and then we'll look at this one about a radio mast. So with a little bit of artisticness there, I've drawn the radio mast 40 meters high, so that's opposite the 60 degree angle. The hypotenuse is the cable, the length of which we're trying to figure out. So we've got a problem that involves opposite and hypotenuse. So that's sine. Sine equals opposite over hypotenuse, generally speaking. And then in this particular case, the opposite is the 40 meters, and the angle is 60 degrees. So we're talking about the sine of 60 degrees. Sine 60 degrees equals 40 divided by the hypotenuse, which is the thing that we've got to figure out. So because the unknown thing is at the bottom of a fraction, that's going to take us an extra little step to work things out. I'll just get rid of my diagram here to give me more space. So I'm going to multiply both sides by the hypotenuse to get rid of the fraction. So that's a degree sign, by the way. So if I multiply both sides by the hypotenuse, I get the hypotenuse times sine 60 is equal to 40. So that's got rid of the fraction by multiplying by the denominator. But I want to get the hypotenuse on its own, so I'm going to have to divide by the sine 60. So the hypotenuse is 40 divided by sine 60, which is something I can just do on my calculator. I think I'm going to need a new pen. These don't last very long, I have to say. Sine 60. Okay, so 40 divided by sine 60. Let's get the calculator on that. 40 divided by sine 60, close brackets, equals 46.1. 46.18, so about 46.2, but actually we've got to do them to the nearest whole meter, haven't we? So 46 meters in this case. So I'm going to get onto my iMath screen now, and I'm going to type in 46 and look at the next question. It says, from the top of a vertical cliff 94 meters high, so that's 94 meters there, a boat B is seen at an angle of depression of 36 degrees. So an angle of depression is from the horizontal looking down. So it's like an angle of elevation, but it's just downwards instead of upwards. So you're standing on the top of a cliff and you're looking down at the sea. The sea is down the bottom there, and the boat is down here at B. So I'm just going to make that diagram on my whiteboard. So there's the diagram with a little more artistic license. The boat is B here. You're standing at the top of a cliff here, so I've made that look a bit more like a cliff. The cliff's 94 meters high. This big blue wobbly thing is the sea, and compared to looking straight ahead, you're looking down at the boat at an angle of 36 degrees, so the angle of depression is 36 degrees. So I could work with a triangle down here, but then I'd have to figure out what the angle in there would be, which would be 90 minus the 36. What I'm going to do instead is work with this triangle up here. So in relation to the 36, that's 94 over there on the left, the height of the cliff. So that would be 94 on the other side as well. I've just got to click on the thing to remind myself what we're trying to find out. How far is the cliff from the boat? Okay, so how far is the cliff from the boat means at the nearest point along the ground. So we're not looking to find out the hypotenuse, we're looking to find out the horizontal distance from the bottom of the cliff to the boat, which is the same as this dotted red line along the top. So I'm looking to find, in relation to the 36, I'm looking to find the adjacent side, because the right angle's there, so the hypotenuse is that diagonal one. So I've got a triangle with 36 degrees, 94, which is opposite to the 36, and the adjacent, which I'm trying to find out. So opposite and adjacent, that's tan. So generally tan equals opposite over adjacent, and I'm just going to ring fence that off, and in this case we've got 36 degree angle, so we're talking about the tan of 36 is equal to 94 divided by the adjacent. I'm actually going to rub out my diagram at this stage and do that whole thing a bit bigger, because I can see it's smudging a bit. So tan 36 equals 94 divided by the adjacent. So we're trying to find out this adjacent side, and because it's in the bottom of the fraction, we're going to have an extra step to manipulate it to isolate it. Okay, so multiplying both sides by that adjacent to get rid of the fraction, you get the 94 on its own when you multiply by the adjacent side, but then over on the left, you get what you had before but multiplied by the adjacent side. So the adjacent times tan 36 equals 94. I'd like the adjacent side on its own, so I've got to divide everything by tan 36. So 94 divided by tan 36 is the answer, and that's something I can figure out on my calculator. So 94 divided by tan 36, close the bracket, equals 129 point something and a little bit, 129. So going over to my iMaths now, I'm thinking that that distance along the ground is 129. So I'll just fill in 129 there to the nearest meter, and we'll mark it 6 out of 6. That's good.